The quadratic formula is a fundamental tool used to solve quadratic equations, which are equations of the form x squared plus bx plus c equals 0. This formula provides a reliable way to find the values of x, the unknown variable, even when other methods such as factorization aren't practical. The quadratic formula is written as shown on the screen. This formula allows you to calculate the solutions, or roots, of any quadratic equation by substituting the values of a, b, and c, which are the coefficients of the quadratic equation. The quadratic formula works for all types of quadratic equations, whether they have real or complex solutions. The first crucial detail is the term b squared 4ac, known as the discriminant. The discriminant plays a key role in determining the nature of the solutions. If the discriminant is positive, the quadratic equation has two distinct real solutions. If it equals 0, there is exactly one real solution, also known as a repeated root. However, if the discriminant is negative, the equation has no real solutions and instead has two complex, imaginary, solutions. The discriminant, therefore, helps predict the type of solutions before even calculating them. The second important aspect of the quadratic formula is the presence of the plus-minus symbol. This symbol indicates that the quadratic formula provides two solutions, one where you add the square root term and one where you subtract it. These two solutions arise from the fact that a quadratic equation is second degree, meaning it typically has two roots. The plus-minus feature ensures both possible outcomes are accounted for. The third crucial detail is understanding that the quadratic formula can be used even when the quadratic is not easily factorizable. Some quadratic equations do not lend themselves to simple factorization techniques, particularly when the coefficients are large or involve complex numbers. In these cases, the quadratic formula is invaluable because it can solve any quadratic equation as long as you correctly substitute the values of a, b, and c into the formula. The fourth point to keep in mind is that the values of a, b, and c must be taken from the standard form of the quadratic equation x squared plus bx plus c equals 0. This means the equation must first be rearranged so that all terms are on one side of the equals sign, with 0 on the other. Only then can you apply the quadratic formula correctly. If the equation isn't in this form, the values of a, b, and c will be incorrect, leading to an inaccurate solution. The final crucial detail is related to simplifying the expression once you've applied the formula. After substituting the values of a, b, and c, the square root must be evaluated carefully, and both the addition and subtraction versions of the formula should be worked through to find the two possible solutions. Sometimes, the solutions may require further simplification, especially if the discriminant is a perfect square or if the coefficients have common factors that can be reduced. In essence, the quadratic formula is a powerful and universal method for solving quadratic equations. Its key components, the discriminant, the plus-minus symbol, the ability to handle all types of quadratics, the requirement to use the standard form, and the need for careful simplification, all contribute to its effectiveness. By mastering these crucial details, you can confidently solve any quadratic equation, regardless of its complexity.